Hello, everybody. This is the second lesson for today's day, lesson 9B, Introduction to Polynomials. So you'll need the blue reference sheet, which has the polynomial definitions. First is the do now, which has all review questions. Remember to pause the video before any practice questions. Try them yourself. You're really only watching the video for notes and to check your work. So here we go. Again, today is the 21st. The first question, solve the following linear system of linear equations algebraically. When you're doing it algebraically, you can use substitution or elimination. Here you have one equation in standard form and another in this x equals form. So you're going to want to substitute. Substitute the x equals expression everywhere you see x in the first equation. 2 parentheses x minus 5y equals -9. So if we know that x equals 3y minus 8, then it should be 2 parentheses 3y minus 8 minus 5y equals -9. Here, instead of x, we put what x equals into the parentheses instead of using the variable x. We know that x equals 3y minus 8. So we distribute the 2 and we create one equation with just one variable. We turned our system into an equation with just one variable, so we can solve it. Distribute means multiply that 2. So 2 times 3y is 6y, 2 times -8, -16. Let's rewrite that equation. Combine like terms, 6y minus 5y. After you distribute, combine like terms, move constants to one side. So we're going to add 15. And 1y is just y. -9 plus 15 is, 16. 16. -9 plus 16 is 7. +7. And now we can find out what x equals since we know what y equals. X is just equal to 3y minus 8. So x equals 3 parentheses 7 minus 8. Type that into Desmos, or just think about it. 3 times 7 is 21. 21 minus 8. Count on your fingers. That's 13. So our answer is 13, 7. Number 2. Simplify the exponent completely using only positive powers. So here we have a -3 outside of the first expression. We need to distribute that -3 to all terms. Let's rewrite the original. Distribute the -3. So it's going to be 3 to the -3 and x to the 5th to the -3. Take apart the second expression, x to the 7th in its own parentheses and y to the -7th in its own parentheses. And let's start simplifying. We know that negative exponents must be written as positive fractions, so 1/3 to the +3. Outer exponents need to be multiplied or distributed inside. So that's x to the -15. Then we have x to the 7th. So let's write them in their own parentheses. And then lastly, y to the -7th, we can go ahead and write that as a positive, 1/y to the +7. 1/3 to the 3rd is 1/27. 3 times 3 is 9, times 3 is 27. X to the -15 and x to the -7 We have two x's being multiplied, so the same base. We're going to add their exponents. And then 1 over y to the 7th. Let's rewrite it. Negative 15 plus 7 is negative 8. Okay, we're getting closer. 1 over 27. Now x to the negative 8 becomes 1 over x to the positive 8. And we're going to keep bringing 1 over y to the 7th. Now we're almost done to simplify. There's no numerator. The numerator is 1. The final denominator is all of these expressions, 27, x to the 8th, y to the 7th. And number 3, compute the value of the expression using PEMDAS, so parentheses first. So we don't do anything to those exponents. We have 4 minus 6 in parentheses first, so we're going to do that. That's negative 2. Put the exponent 2 outside. Then we do exponents. So 3 to the 4th. We saw earlier 3 to the 3rd was 27, so 27 times another 3, 81. 3 to the 3rd, 27. Bring down the minus sign. Negative 2 to the power of 2 is positive 4. Negative 2 times negative 2. There's a minus sign in front, so now we have 81 plus 27 minus 4. Left to right, that is 54 minus 4, 50. Okay. Next page. So jumping into today's topic, using what we've seen, we've started to look at exponents more deeply, exponential expressions. What is this big question? What is the difference between x squared plus x and x squared times x? Can these expressions be simplified further? Rewrite both expressions using the operations you see and be prepared to share your reasoning. So let's split the workspace in half. X squared plus x, and then x squared times x. We're going to use the multiplication dot instead of the times sign because it looks like x. What do we know about exponents, x to the power of 2? Well, we know that exponents are used for multiplication, x times x. So that first one would be x times x plus x. And the second one would be x times x times x. Which one can be simplified would be the one with all the multiplication. The one with addition can only be brought back to x squared plus x. These are not like terms. The original two, x squared and x, even though they have x, they're not like terms because one has an exponent and one doesn't. So you can't add them. The exponents are different. So write this down, not like terms. Different exponents. We can't combine / add. To combine like terms means you add or subtract the like terms, and you can't do that here. The next one, though, x times x was x squared, so x times x would be x cubed, or x to the power of 3. Or you could have thought of it as x squared times x is x squared times x to the first power. And when you're multiplying, only the bases need to be the same. And you can add the exponents. So x to the 2 plus 1. So this was simplified to one term. Next page. And so some definitions for us, that x squared times x, which became one term, is actually called a monomial. a monomial has the word mono in it, meaning one. It's a non-zero single term, underline that, single term expression that is the product of constants and variables, where variables are raised to non-negative integer powers. So x to the third would be a monomial. X to the power of 2 would be a monomial. 5x squared. They're all one expression. Even the number like 9 or negative 3x squared, negative 4x to the fourth. Those are all monomials. A binomial, bi means two, like a bicycle, is when you have a sum of two monomials. So when you have an addition or subtraction sign, x to the third plus 5, x squared minus 1, x squared plus x. So two different monomials getting added together, and they cannot be combined. They're not like terms. They're written side by side. Even x squared minus y squared, x cubed minus y. Trinomial is three terms, three monomials. X squared plus 5x minus 4. X squared minus 3x minus 9. 4x to the fourth minus x to the third plus 2x to the second. So put the commas in between. Everything that has three terms. 1, 2, 3. 1, 2, 3. 1, 2, 3. A polynomial, poly is the opposite of mono. Poly just means many. So anything that's a binomial or above is a polynomial. And those are the things we're going to study in today's lesson. So anything like a binomial, x cubed minus 1. Anything like a trinomial, these are all polynomials. It could have 8 terms if it wanted. I just wrote one with 4 terms at the last. Okay. Let's keep going to some more definitions. So now we're going to look at polynomials, these expressions with many terms separated by addition or subtraction. We want to write them in the correct form. We write them in descending order. That means the greatest value first. Here, the greatest value is the one with the biggest exponent. So circle the n, circle n minus 1. This one would be x to the invisible 1 power. And this one would be x to the 0. There is no exponent next to it. I'm sorry, there is no x at all. When there's, let me repeat. When there's just x by itself, it has an invisible 1 on it. When you have a number like a0 with no x, no variable, that will be x to the power of 0. We write it with the highest x or highest variable first. This is the standard form of a polynomial, with an xn being the leading term. A0, AO is the constant term, or the term that does not contain a variable. We've seen that before in y equals mx plus b. The b value is the constant. It's the y-intercept. Okay. Next page. Or sorry, let's do the quick check at the bottom. Circle the leading term and underline the constant term of each polynomial given below. Pause the video and then play it to see the answer revealed. So pause now, and the answers will be revealed. And so again, the leading term, we'll see the answers now. The leading term is the one with the highest variable, x to the power of n. Here, the leading term will be 7x to the 4th, the leading monomial. And the second one, it will be 8x to the 7th. And the last one, 9x to the 4th. It's written in the front because it has the highest variable. The constant term is the one with no variable. So here in the first one, it's plus 3. And here in the last one, it's plus 3. The middle one, what number can you add without changing the value of something? You can add 0. So the constant here is 0. Right? Anything plus 0 wouldn't change. So 4 plus 0 is 4. This whole expression plus 0 is just this expression. Or you could say it has no constant. The constant is 0. Let's keep going. More definitions. Within the leading term is the degree. So inside of the leading term is the degree. We can determine the degree of a polynomial in 2 ways. First, it could be the greatest degree of any of its monomial terms. So if you see just one exponent and it's the biggest one, that's the degree. But if your polynomial is a little complicated, if it has more than one variable in each term, in each monomial, you need to find the greatest sum of the exponents of the variables in any single term of the polynomial. Okay? And so here's an example. Your leading term is this whole 3x to the 4th, but the degree is just 4. The degree is 4. The y-intercept slash the constant, write it down, constant, is -7. There's a minus sign in front of our 7, and it has no variable. Let's keep going. Determine the degree and leading term of the polynomials given below. Take a second, pause this video, try it yourself. Pause it now. And hopefully you've paused and we can come back together to see the answers. Determine the degree and leading term of the polynomials given below. So the degree is the highest exponent. Write that down, highest exponent. And the leading term is what the degree is on. So I think the fastest way to do this is to go through each monomial and determine its degree. The degree of the first one is 7, so let's put a little 7 under it. The degree of the highest exponent of the second one is 3. The 9x has a degree of 1. The exponent is 1. And the -10 has a degree of 0. It has no variable on it, x to the 0. So what's the degree of the entire polynomial? 7. And the leading term is 4x to the 7th. In the second one, what's the degree of 9x? Well, there's only one x there, and it's x to the 1. So the degree is 1. What's the degree of 8xy? This is the first time we're seeing 2 variables in the same monomial. X is to the 1, or first power, and y is to the first power. Our note on the last page says we need to find the greatest sum of the exponents of the variables. So the sum here would be 1 plus 1. The degree is 2. The degree of the second term, -10x squared y cubed, 2 plus 3 would be 5. Then the next one, 4. And the last one, 2 plus 1 would be 3. The overall degree is 5, and it's part of this negative monomial. So the degree is 5, and the leading term is -10 x squared y cubed, or y to the 3rd power. Finally, what is the constant term of this polynomial? Constants, underline it, have no variable. So the constant here is 6. Choice A, +6. Let's keep going, some notes. Simplifying polynomials. We can simplify polynomials using algebraic properties. Underline that, simplify them. The first one is the commutative property. Commutative property just basically means, well, when we learned it first, like back in 4th grade, 3 plus 4 is the same as 7. Actually, I think that's... So we can simplify polynomials using algebraic properties. The first one is the commutative property. The commutative property tells us that we can combine like terms, which are terms with variables that have the same exponents. In the guided practice, we saw that we couldn't combine x squared plus x. Although they're the same variable, they didn't have the same exponent. Like terms need to have the same exponents. When ordering and combining terms in a polynomial expression, you want to use the sign in front of the term. So if it's to tell you if it's positive or negative. If you don't see a sign in front of the first term, it must be a positive number. Okay? So like this first term, it's a positive 4 x squared y to the third power plus 3x to the third power y to the second power minus 2x to the second power y to the third power. The positive 4 term and the negative 2 term are like terms. But that middle one is not, because the exponents are different on x and y. The second property we're looking at is the distributive property, which we know and love. Distributive property tells you to multiply the term directly outside the parentheses to every term inside the parentheses. And we've even done this with exponents. Next page. Based on these two properties that we've seen for quite a while now, try simplifying problems 1 and 2. I'm sorry, 1 through 4. Pause the video for pages 8 and 9 of the packet, and then come back, and we will review them. Okay, so looking at this next round of independent practice, how do you simplify these 4 problems? In the first one, we have to use the commutative property, combining like terms. What are the like terms here? Let's underline the first set we see. 3x plus 5x. They both have x, raised to the first power. The second set of like terms, let's underline them 2 times. Negative 9 minus 10. They're both constants. So 3x plus 5x makes 8x. Negative 9, that's a negative 9, minus 10. You can circle if you need to. Negative 9 minus 10 is negative 19. That's your final answer. You can't combine them further. So that's your final polynomial. In number 2, how do you simplify this polynomial? You're first going to distribute. There's a 4 in front of the first term. There's a negative 7 in front of the second group. So we're going to distribute positive 4. You get 4x. 4 times negative 9, negative 36. Then we're going to distribute negative 7. What happens when you distribute a negative number, or when you multiply by a negative number? Signs flip. So this positive 12 becomes negative 84. This negative 5 becomes positive 35. X. Then we use combine like terms. So we do 4x, underline it once, and we look left to right. Are there any other x terms? Yes, 35x. Underline it once. We underline the constants twice, so negative 36 and negative 84. 4x plus 35 x is 39x, negative 36 minus 84, negative 120. Simplified, can't combine any further. One has x, one is a constant. Number 3, 3x to the third plus 7x squared minus 10x plus 7 minus 15 plus 9x minus 17x plus 12x to the third. Whew. So we should just look left to right and underline all like terms as we go. So the first one, we look for the biggest exponent, which is 3. 3x to the third power, underline it once. Are there any like terms to it? Yeah, all the way at the back, there's a positive 12x to the third. Underline it. What's the next highest exponent? 2. 7x squared. Underline it 2 times. Are there any like terms? Nope. So we move on. Negative 10x to the negative 10x. Underline it 3 times. That's our next term. And it has 2 like terms. Positive 9x and negative 17x. Underline them 3 times. Lastly, negative 7 plus 15 are constants. Let's box them where we don't want too many lines getting confusing. So we can write this together with like terms next to each other. 3x cubed plus 12x cubed plus 7x squared minus 10x plus 9x minus 17x, and then plus 7 minus 15. Underline that once, twice, 3 times. Don't forget the negative sign in front of 10. And then we can box our constants. 3 plus 12 is 15, x to the third, plus 7x squared, negative 10 plus 9 minus 17, negative 18x, and 7 minus 15 would be negative 8. We are done. We've simplified all the like terms. And the last one, number 4. When you have expressions like this, first thing to do is put all those invisible exponents on your variables that have just the letter. Put the invisible 1 exponent on them. So anywhere you see just a variable, put a little 1 on it. 7x squared y to the first. 8x to the first y to the 1. Then we look for like terms. 7x squared y to the first. We're looking for any other term that has that variable and exponent combination. X squared y to the first. This last term has x squared y to the first. It's just written backwards to trick us. So let's underline these one time. Negative 8x to the first, y to the second, has a like term. The other negative 8 also has x to the first and y to the second. So those two are like terms. Let's underline these two 2 times. Let's rewrite it with x in front of y, just like our alphabet. Let's put the like terms next to each other, but that 11 term, we're going to put x squared in front of y. Same with the negative 8, so we're going to put x, then y squared, minus 8x, then y squared. So it's easier to read. Underline those one time. 7 plus 11 is 18, x squared y. We don't change the exponents. We just bring them down because these are like terms. When we do 9x plus 1x, it becomes 10x. We don't change exponents when we're adding. We just bring them down. Here, we do negative 8 minus 8 to get negative 16 xy squared. Bring the variables down with it. Okay. Next set of notes, page 10. A topic we know pretty well, and a word we've heard a lot is evaluate. We've seen the word evaluate appear in multiple grades, word problems, and topics in math. To evaluate an algebraic expression or equation, you're going to substitute, write it down, substitute the numerical value of a variable into an expression or equation wherever the variable appears. So you literally change the variable into that number. You must always draw parentheses around the variable that you're about to change into a number. So here in this example, x is equal to -3. So notice the square, the exponent, is not inside the parentheses. The original 3 and the original 2 are not inside the parentheses. Only -3 is. All right, try the next round of practice. It says number 4. It's actually number 3. The next round after that will be round number 4. But pause the video here. Try it. Use parentheses wherever you see x and wherever you see y for number 1. Okay, we'll be right back after you practice. So for the first one, we have a value for x. It's equal to -4. And for the second one, y equals 2. Draw parentheses wherever you see x and wherever you see y. The first y has an exponent 2 on it. Leave that 2 outside. When rewriting it and showing your work, you might just want to use blank parentheses and like under it, label it with your variable. So here, oh, and don't forget the exponent 2 there, like I almost did. We do 3, parentheses -4, parentheses 2, exponent 2, -3, parentheses -4, -4, parentheses 2. Type that all into Desmos and we should get -68. Don't forget the little exponent 2 here. Don't forget all your parentheses. Number 2, evaluate f of -5 if f of x is equal to -x squared plus 9x minus 12. So here, x is equal to -5. We want to draw parentheses just around x so that the negative and the 5 are both being represented in the equation. If you don't use parentheses, your calculator will do it incorrectly. So again, wherever we see x, we're going to replace it. Let's rewrite everything else. Here it's f of -5. So we have negative parentheses -5 parentheses squared or exponent 2 plus 9 parentheses -5 minus 12. Lots of negative signs to keep track of. Make sure you write down all your work. You get -82. Okay. Next round of independent practice. Pause the video and try it, and then you'll be done with that. You can do the exit ticket. Okay. Okay, so on page 11, I hope you have paused the video and now are reviewing your answers. For number 1, determine the degree and leading coefficient of each polynomial. So again, you'll have to use your reference sheet and our notes. There's a lot of new definitions to keep track of. For the degree is the highest exponent. Let's label it if we forgot. Highest exponent. And the leading coefficient is actually the number in front of the leading term. So let's look for the highest exponent first. In the first one, the first exponent is 6. The second exponent is 4. The next exponent is 1. And the last one has an exponent of 0. Constants have an exponent of 0. They have no variable. So our degree is 6. The leading term is 5x to the 6th. The leading coefficient is the number in front of a variable. Look at your blue sheet for today. What is a coefficient? Coefficient is the number in front of a variable. So in this case, it would be 5, which is in front of x to the 6th. The degree of the next one. In the first term, you have 1x, so it's x to the 1. And you have 1y, so it's y to the 1. That has a total degree of 2. The second one has a degree of 1. It's just x to the first power. And the last one has no variable. It's 0. The degree is 2. The leading coefficient, what's in front of xy? Well, let's write it on the bottom here, xy. It's actually 1 xy, so the coefficient is 1. And for the first example, let's go back. 5x to the 6, let's write the whole leading term, underline the 5, underline the 1 here. And for 9, has a degree of 0. There's no variable, it's a constant. There's no leading coefficient. They're both C words, but remember the difference. A constant is a number that stays the same. It has no variable. A coefficient is in front of a variable. So this one doesn't have a coefficient. 9 is a constant. Number 2, determine the standard form of each polynomial to obtain their leading terms. So we want to write these in standard form. That means the highest degree in front. For the first one, let's go through each term. The degree of the first one is 0, then 1, then 2, then 3, and then 4. So this one's literally written in reverse order. We need to write it in the right order. Negative 11 x to the 4th, because that's the highest one, plus 9x to the 3rd, minus 4x to the 2nd, plus x plus 9. Positive x and a positive 9. Your leading term is negative 11x to the 4th. The whole term is negative 11x to the 4th. Okay, a lot of different definitions inside of these same things. Look back in front of that blue sheet for today. The whole leading term is negative 11x to the 4th. The degree is 4. And the coefficient is negative 11. Okay, this question wanted the leading term, so we're going to box the whole thing. In the next one, the first term has a degree of 1, then 3, then 0, then 2. So we write 7x to the 3rd first, then 9x squared, 8x, minus 12. 7x to the 3rd is the leading term. Box it. Number 3, x is raised to the invisible 1. Y to the 2nd has a degree of 3. 7xy has a degree of 2. There's 1x, there's 1y. The third one has a degree of 3. And the last one has a degree of 2. So the highest degree is 3 here, but 2 terms of that degree. We follow the rules of the alphabet. This one is the leading term because x is raised to the power of 2. Here, this one's only raised to x to the power of 1. And x comes first in the alphabet. So we want to write that highest x value first. Negative 9x squared y plus xy squared plus 7xy plus 9y squared. This is our leading term. It's tied for the highest degree, so we follow the rules of the alphabet and we go with x, highest x before highest y. Number 3. Evaluate the function at the given values of x. So x is -3. Wherever we see x, we draw parentheses. 8 parentheses minus 12. In the parentheses, we put a -3. We type it in left to right on Desmos and we get -36. And the next one, x is 2. Leave the power of 3 outside. So g parentheses equals 9 parentheses exponent 3 minus 7 parentheses plus 10. Put 2 inside. Type it into Desmos. It's positive 68. And the last one, x is -5. So h parentheses equals negative sign first, parentheses, exponent 2 plus 4. -5 goes in the parentheses. So you have a double negative and an exponent 2 outside. You're going to get -21. Okay, next page. Simplify these and express them in standard form. So that means highest degree first, or highest degree order. When it says simplify, we think of distribute and combine like terms. Here we can combine like terms. The -9x and -10x will go in front. They have a degree of 1. And then the constants, 7 plus 20, will go behind them. So let's write it. -9x minus 10x plus 7 plus 20. Underline -9x minus 10x once. Underline 7 plus 20 twice. Get -19 plus 27. Number 2. 3x squared, underline it once, and 9x squared. Then we have plus x and plus 12x. Underline those two times, sorry. And then your constants, underline them 3 times. Let's write them side by side. 3x squared plus 9x squared. And then plus x plus 12x. -9 minus 12. 3x squared plus 9x squared is 12x squared. X plus 12x is 13x. And -9 minus 12 is -21. Next, highest degree looking from left to right is x to the third. So 3x to the third minus 7x to the third. Then 3x squared, underline it 2 times. Minus 4x squared, underline it 2 times. Minus x plus x, underline those 3 times. And then box your constants. Plus 7 minus 12. 3 minus 7 is -4, x to the third. 3 minus 4 is -1. -x plus x is 0. Those are opposites. They cancel. 7 minus 12 is -5. And when 1 is your coefficient, when 1 is in front of a variable, you leave it invisible. That's just telling you there's 1x squared, or just x squared. Okay. So that middle term has a coefficient of invisible 1. Number 5, compute the following exponent without negative powers. -5 to the -3rd power, review from last week. We write it as a positive we flip the base. So the base is -5. We write it as 1 over -5. And then our exponent -3 becomes +3 in the denominator. The -5 doesn't change to +5. It just goes into the denominator. It gets flipped. -5 to the 3rd power is -125. You have to use parentheses for your calculator to read it right. And so we just say the whole answer is -1 over 125. You could type the whole thing, the original, into Desmos, and it'll pop out the answer for you. But here's the work. For number 6, we have a recursive function. It's defined recursively, underline that, meaning it's a 2-part function. They tell you the first term and then tell you the rule to follow. It says the first term is 4, and then every term after that is 3 times the last term minus 7. They're trying to trick you because we're used to seeing it as n minus 1 and n, but n plus 1 and n is the same thing. Let's draw a number line. If n is in the middle, n minus 1 is before it, and n plus 1 is after it. So if we're looking for a2, we do 3 times, let's go back to our number line. If a2 is the number we're looking for, if that's n plus 1, the number before it was a1, which we have. a1 is 4. So 3 parentheses 4 is 12, minus 7 is 5. We could type that into Desmos. a3 will be 3 times the number before it, a2, minus 7. 3 times 5 minus 7, which is 8. a3 and a2. Okay. Number 7. For which values of x will the following set not form a function? Underline that, not form a function all the way back from day 1. X repeats for something that's not a function. And so if we're looking for something to fill this point that would make it not a function, we have to look at something where x repeats, where x has more than one output. So the x's we already have are 4, 5, 10, and 7. But 7, if 7 was our x value, it would still be a function because the output 7 already has is 9. And this x that we're looking for has an output of 9. So that point would just live on itself, and it would still pass the vertical line test. So the x values that would not make this a function are 4, 5, and 10. Write that down. X equals 4, 5, or 10 would make this set not be a function. Because x would have more than one output. X could be 7 because it would still have one output. The output would be 9. But for all the others, x would repeat. X would have more than one output. For number 8, we underline the is and of statements based on the table below. What fraction of home games, so let's box it, of home games were losses? Of is our whole, tells us what the whole total we're looking for is, and the part comes from this is statement. is losses? What part is losses or were losses? So first we calculate the number of home games, 68 plus 11. We go down this column. That's 79. Circle the amount of losses in that column, 11. And your fraction is 11 out of 79. 11 out of 79 of home games were losses. Number 9, simplify the following expression as a polynomial completely in descending degree order. So it has a lot of variables in each one. Let's label all the invisible exponents. And let's also make sure y comes after x. So this one has a degree of 2. This one has a degree of 2. This has a degree of 3, 2, 3, 2. So let's look at those degree of 3 terms first. 7x squared y to the first. 7x squared y to the first and 5y to the first x squared. These have the same exponents on their variables. So they are like terms. We write x before y. Then we bring the rest down. Plus 5x squared and plus 7x squared are like terms. Minus 9xy minus 9xy. Write x first. So these are like terms. These are like terms. And these are like terms. Negative 9 minus 9. Those don't cancel. Those are not opposites. That just makes it more negative, negative 18. And we have our simplified answer. Number 10. The age of teachers at Forte Prep are listed below. So here's 15 teachers. Draw a box and whisker plot for the data. First, you need to type in this list as a letter, capital letter, D equals bracket. Draw your bracket. Type in all of this onto Desmos, just like that. D equals bracket 29, comma, 32, comma, and so on. For a box and whisker plot, you're going to use the stats function, type stats, parentheses D, and you should get the 5-number summary, and you can draw your box plot. Try your best to space it out evenly. We're going to go up by 10s, kind of like Desmos shows us. So the minimum is 25. The Q1 is 30. Median is 34. So kind of in the middle of 30 and 40. A little closer to 30. Q3 is 40. And the maximum is 55. So right between 50 and 60. Connect Q1 to Q3 in the middle and draw your tails, your whiskers, to the minimum and the maximum. Okay. Don't forget to label those on the side. Minimum 25. Q1 30. Median 34. Q3 40. The max 55. Let's write it on the side. To find, oh, we have some of these values already. So we have Q1. We have Q3. We have the median. We can find the IQR pretty quickly. That's just Q3 minus Q1. Or 40 minus 30. So that's 10. The range is actually the maximum minus the minimum. 55 minus 25. So the range is 30. Interquartile range is Q3 minus Q1. The whole range is the maximum minus the minimum. The mode you'll find using a dot plot like we did first week. There is none. There's no higher stack on any number. And the mean you just find using mean parentheses D. That's 35.6. Repeating. Lastly, number 11. Which of the following polynomials has a degree of 5? Circle your answer. Let's go through each choice. Choice 1. First term has a degree of 4. Exponent is 4. The second one has a degree of 2. Then 1. Then 0. No degree of 5. The second one, choice 2, is a constant, has a degree of 0. Let's write it down. The first one has a degree of 4. The second one has a degree of 0. Number 3, the constant starts, that's a degree of 0. Then 3, add them together. Then 4, and then 5. So that has a degree of 5 there as its highest degree. And for number 4, the first term is 3 plus 3, has a degree of 6. Second one has a degree of 4. The last one has a degree of 4. So the fourth option has a degree of 6. The third one has a degree of 5. Choice 3 is our answer. Please complete the exit ticket and be ready to hand in the 2 exit tickets and your homework tomorrow. All right. Thank you so much. See you again.